Let's practice evaluating powers of I together. Before we can evaluate powers of I, we need to know the first few powers so we can see a pattern that's going on here. First of all, we can start with I to the 0th power. Now I to the 0th power is just equal to 1 because anything to the 0th power is equal to 1. Next we have I to the 1st power. Now anything to the 1st power is just equal to itself, so I to the 1st power is just equal to I. The third one we want to know is going to be I squared, and I squared is equal to -1. To understand why I squared is equal to -1, we want to remember what I is defined as. Now I is defined as the square root of -1, right? So if we go ahead and square both sides of this, if we square the left side and square the right side, then on the left side we will have I squared, and on the right side, if we square the square root of -1, that's just equal to -1. So hopefully you can see where that I squared equals -1 comes from. The third power of I that we want to memorize is that I cubed, where I to the 3rd power is equal to -I. Now there's no real need to memorize this one because if we take a look at our powers, if we have I to the 1st power and we multiply that by I to the 2nd power, that should equal I to the 3rd power, right? So if we multiply I to the 1st power by I to the 2nd power, that should equal I to the 3rd power. By our product rule with exponents, we just go ahead and add 1 plus 2 equals 3. But by that same token, we should be able to see that I multiplied by -1 should equal -I. And if we can see here that if I to the 1st power is equal to I, and I to the 2nd power is equal to -1, then I times -1 is equal to -I. For the fourth and final power of I we want to memorize, we have I to the 4th power, and that's equal to +1. Now to prove where I to the 4th power comes from, one way we can do this is we can take a look at this I to the 1st power, multiply that by I to the 3rd power, and that'll equal I to the 4th power. So if we go ahead and write this out, we have I to the 1st power, we multiply it by I to the 3rd power, again that should equal I to the 4th power, right? If we add those two exponents, 1 plus 3, that's going to equal this 4 here, right? Now we know I to the 1st power is equal to I, and we know I to the 3rd power is equal to -I. So if we multiply I times -I, that's going to be -I squared. Now think about this a little bit further. We know that I squared is equal to -1, so this is going to be a -1, right? And -1 is equal to +1. So that's one way we can think about it. Another way we can think about it is if you multiply I squared by itself, I squared times I squared, that should also equal I to the 4th power, right? If we write that out, it would be I squared multiplied by I squared, and that'll equal I to the 4th power, right? Now what is I to the 2nd power? Well, I to the 2nd power is equal to -1, and if we multiply -1 by -1, we also get +1. So there's two ways to think about why I to the 4th power is equal to +1. If we know that I to the 0th power is equal to 1, I to the 1st power is equal to I to the 2nd power is equal to -1, I cubed equals -I, and I to the 4th power is equal to 1, we can go ahead and evaluate any power of I a lot easier. So for number 1, we have I to the 8th power, and you want to remember your rules of exponents. You can really break this down into I to the 4th power times I to the 4th power, right? And you can add those two 4s to get 8. Now I to the 4th power is equal to 1, and so we have 1 times 1, and so this whole thing is really just equal to 1. Okay, now that's one way to think about it. Another way to think about it is every 4 i's multiplied together always gets 1. So if we go ahead and just group them always into groups of 4s, 8 divided by 4, you're going to notice that that's going to be 2. 2 times 4 is 8. And the remainder here of 0, that kind of tells us everything we need to know here. Okay, this remainder of 0 lets us know that we can rewrite this as I to the 0th power. Okay, so if it goes in evenly, that remainder tells us what we can simplify each of these powers down to. Now I to the 0th power, that's just equal to 1, so that's another way we can get the same answer here. Okay, now the remainder is going to tell that each time. Now for number 2, I'm also going to write this out long ways, but we can say this is I to the 4th power times I to the 4th power times I to the 4th power times I to the 3rd power, right? So this is if we break them down all the way. So we have 4 plus 4 plus 4, that's 12. 12 plus 3 is 15. So each of these I to the 4th power is equal to 1. So it's 1 times 1 times 1 times I to the 3rd power. And if you look closely at this I to the 3rd power, you can see this I to the 3rd power is equal to -I. So this whole thing simplifies down to just being -I. Now, using a little bit of shortcut here, let's practice taking this 15, that's the power, and dividing by 4, because every group of 4 equals just 1, so 3 times 4, that's going to equal 12, and we get a remainder of 3 here. Again, if you just go ahead and do the long division, this remainder of 3 lets us know that you can also just write this as I to the third power. Whatever the remainder is, that's how we can go ahead and write it, okay? And so if you take a look at this I to the third power, that's equal to negative I, so we can go ahead and say this is equal to negative I. All right, so that's a little bit faster way to do it, because if you just divide each of the exponents by 4, the remainder is always going to tell us the most simplified version of how we can write these. Okay, I'll write out maybe just 1 or 2 more, and then I'll just use a shortcut for the rest of them. But we're really trying to see I to the 5th power is equal to I to the 4th power times I to the 1st power. Okay, now I to the 4th power is equal to 1, and this is really just 1 times I, which is equal to I. Okay, now another way we can think about this again is take that 5, which is the power, and then divide it by 4. 4 fits into 5 one time. 1 times 4 is 4, and you get a remainder of 1. So this remainder of 1 is really telling us what the power is if you simplify this thing. So it's going to be I to the 1st power, which is really just equal to I. So you can see either way we do this, we get the same answer. 1 takes a little bit less work though, instead of writing them all out, especially as the powers get bigger. All right, so moving on to number 4, we have I to the 6th power, and you can write this as I to the 4th power times I to the 2nd power, right? And so I to the 4th power, that's equal to 1, so it's 1 times I squared, and I squared equals negative 1. All right, so again, you want to memorize your first 3 if you can, or first 4 rather, powers of I, starting with I to the 0th power, and that makes that a lot easier to then evaluate. Now again, the shortcut is take the exponent of 6 and divide it by 4. Goes in 1 time. 1 times 4 is 4. You get a remainder of 2. Notice this 2 here is really what we can simplify the whole power of I down to. So it's going to be I to the 2nd power, and that's equal to negative 1. So that checks out because we get the same answer either way. So now you can see for like number 5, right? This exponent of 19 is pretty high, and I don't really want to keep writing I to the 4th power over and over and over again, but how many of them fit inside of it? Well, you can just take this 19 and divide it by 4, okay? Very quick. 4 times 4, that's going to equal 16. 19 minus 16 is equal to 3. So if you know the remainder is 3, then we can just right away take this and say this is equal to I to the 3rd power. Okay, so we're just getting rid of 4 groups of I to the 4th power. And if you know I cubed is equal to negative I, then you are all done. Okay, it's as simple as that. For number 6, we have I to the 23rd power. So we can take this 23 and go and see how many times 4 fits into it. And so 4 times 5, that's going to equal 20. So we have a remainder of 3. All right, so we would have 3 i's left over, and so we can say that this whole thing can be boiled down into just I to the 3rd power. And if we know it's I to the 3rd power, just like in number 5, this will equal negative I. That would be the value, okay? For number 7, we have I to the 21st power. What we can do is take this 21 and then divide it by 4. And 4 goes into 21 5 times. 5 times 4 is 20. We get a remainder of 1. Right, so that means that basically we can fit in 5 of the I to the 4th powers, but what we have left over is just going to be I to the 1st power, and I to the 1st power is just equal to I. For number 8, we have I to the 38th power, so let's see how many 4s fit into 38. So take 38 and then divide it by 4. I think 9 times 4 is 36, as close as we can get. We get a remainder of 2. And so this remainder of 2 lets us know that we are going to have I to the 2nd power left over here, okay? Now I to the 2nd power, that's equal to negative 1. So let's go ahead and put that in, and that would be our final answer, okay? We would have 9 of those I to the 4th powers, but they all become 1. So 9 1s multiplied together is still 1, and we have that I squared left, which is equal to negative 1. All right, moving on to number 9, let's give a few more a try here. So we have a power of 33. So if you take 33 and then you see how many I to the 4th powers fit inside of there, I think we can fit 8. 8 times 4 is going to be 32. So we're going to get a remainder of 1. So this remainder of 1 lets us know that we can actually instead of writing I to the 33rd power, we could just go ahead and write I to the first power because it's much smaller and it means the same thing. And so I to the first power is just equal to I. For number 10, we have I to the 59th power. Definitely don't want to go ahead and write out all the I to the 4th powers that fit inside of that one. So if we divide it by 4, that should save us some time. 4 fits into 5 one time. 1 times 4 is 4. We get a remainder of 1, bring down this 9. 4 times 4 would be 16, and we can see that we get a remainder of 3. So we could fit in 14 of those I to the 4th powers, and we can see that all we'd be left with is going to be I to the 3rd power, right? Now I to the 3rd power, or I cubed, that's equal to negative I, and so that's what this would simplify into. All right. For number 11, we have I to the 84th power. So you can take this 84, and let's see, let's divide that by 4. 4 fits into 8 2 times. 2 times 4 is 8. 8 minus 8 is 0. Bring down this 4. 4 fits into 4 one time. 1 times 4 is 4. And you get a remainder of 0. Okay, so this remainder of 0 means that we can simplify this I to the 84th power just down to I to the 0th power. And keep in mind that when you have anything to the 0th power, especially I to the 0th power, in this case, we just get 1. So when you have no remainder, it's always equal to 1. All right, moving on to I to the 51st power, you can take 51 and just divide that by 4. 4 fits into 5 one time. 1 times 4 is 4. 5 minus 4 is 1. Bring down that 1. 4 fits into 11 2 times. 2 times 4 is 8. And we see here that we have a remainder of 3. So we have a remainder of 3. That lets us know that I to the 51st power is the same thing as I to the 3rd power. And if we know that I to the 3rd power is equal to negative I, then that's as far as we have to go. That would be what the solution is. On to number 13, we have I to the 45th power. So we take this 45. Let's go ahead and see how many 4s fit inside of it. So 4 fits into 4 one time. 1 times 4 is 4. We get a remainder of 0. Bring down this 5. 4 fits into 5 one time. 1 times 4 is 4. We get the remainder of 1. So this means that we can take this I to the 45th power, and we can just simplify that down to saying that's the same thing as I to the 1st power, and I to the 1st power is just equal to I. So that would be our solution. For number 14, we have I to the 100th power, okay? So I know it seems pretty high, but let's see, it's not too bad. If we divide this by 4, 4 times 2, that's going to be 8. Remainder is 2. Bring down to 0. 4 times 5 is equal to 20. So you can see we have a remainder of 0. Again, if we have a remainder, that lets us know what we can simplify this down into. This simplifies to I to the 0th power, and I to the 0th power is always equal to 1. So when you don't get a remainder, you always get 1, or when your remainder is 0, right? So if you take a look at 15, we have I to the 93rd power. So let's take this 93. Let's see how many 4s fit inside of it. So 4 times 2, that's going to be 8. We have a remainder of 1. Bring down to 3. 4 times 3, that's going to be 12. And so 13 minus 12 is 1. And so this remainder of 1 lets us know that we can rewrite I to the 93rd power. And the same thing would be I to the 1st power. And I to the 1st power is just equal to I. So that would be our answer. Finally, for number 16, we have I to the 392nd power. So let's take this 392 and see how many 4s fit inside of it. 9 times 4 is going to be 36. And so we see that we're off by 3. Bring down this 2. 8 times 4 is going to be 32, and we have a remainder of 0. So this remainder of 0 lets us know that this I to the 392nd power is just going to be the same thing as I to the 0th power, and I to the 0th power is equal to 1. So that would be the same thing, you're just using a much lower exponent. And so there you have 16 different practice problems on evaluating powers of I. Now keep in mind that no matter how high these exponents are, it doesn't matter, they're all the same. You just take those exponents and divide them by 4. Each time you look at your remainder, it's going to be 0, 1, 2, or 3. Those are the only remainders they could be. And based on that, it's either going to be I to the 0th power, I to the 1st power, I to the 2nd power, or I to the 3rd power. If you know what each of those are equal to, you know what that whole power is equal to. Now here's a little chart that you might find helpful, okay? So we have I to the 0th power, that's just equal to 1, because anything to the 0th power is 1, we said. Now I to the 1st power, that's still equal to I to the 2nd power, that's equal to -1, and then I to the third power, we said that's going to be equal to negative I. Now, what about I to the fourth power? Well, once we reach I to the fourth power, that's back to being 1 again. I to the fifth power, that's equal to I to the sixth power, that's equal to negative 1 again. I to the seventh power, that's equal to negative I, right? And then when you say I to the eighth power, that's back to being 1. I to the ninth power, that's equal to I to the 10th power, that's equal to negative 1. I to the 11th power, that's equal to negative I again. And I'll go through one more cycle. If we have I to the 12th power, that's also equal to 1. I to the 13th power, that's equal to I to the 14th power, that's equal to negative 1. And I to the 15th power is equal to negative I again. So if you look at this first column, you can notice their powers. So you can see every 4 is going to equal 1. So that's why we divide by 4. And if you look at all of these ones over here, notice how these exponents are all 4 away from each other. And if you divide all of these numbers by 4, you'll always get a remainder of 1, which is why they're all going to be the same. Once again, all these exponents are 4 away from each other. And if you take any of these numbers and divide by 4, you're always going to get a remainder of 2, which is why they're all equal to negative 1. And finally, for all of these ones, we have 3, 7, 11, 15. Notice they're all 4 away from each other. And if you divide any of these numbers by 4, you'll always get a remainder of 3. So this pattern continues on and on forever, but hopefully this helps you kind of see that pattern a little bit more of why we divide by 4, because they always go in groups of 4. And the remainder lets us know how to kind of write that evaluated power version. Now, I hope you found this video helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.